Hey everyone, the video today is going to be about an introduction to functions. So functions is the main core of Plexus Lab, and it's where we're going to write all the logic that is going to control our automation system. So we're going to divide this video into 5 sections. First, we're going to see an overview of the functions page. Second, we're going to see the API list, which is the blocks of the pre-made functions. Then third, we're going to talk about function rules, and we're going to have a first example of reading and writing a variable. And number 4, we're going to see how to custom build our blocks. And in the 5th section, we're going to just have a final example. So let's get into it. Let's log in into Plexus Lab. On the left, we'll click on Functions. And this is the function page. So on the left side of the page, we're going to have the list of our functions. Here we pre-wrote a couple of functions here for you. We have the Add Function button, which let us add a new function. We can edit the order of these functions, which is very important. I'm going to show you later why this is so crucial. We have a little indicator that tells us how fast our functions are running at right now. And on the right, we have our function itself, the title of the function we selected, the whole main body of the function itself. And then on the top right, we have a series of buttons. So the first one, it's a find box. So right here, we can type any search keyword that we want, and pretty much this is going to find inside all the functions where we wrote a specific command. So it's very, very useful when we need to search, when we have a lot of functions written, when we need to search where we wrote about a particular variable. The second one is to fold the code. I will explain this a little bit later. Then we have the save function button, the upload function button, debug viewer that will show the messages that could come from functions itself, the list of API that we're going to talk about now, and then an info. So in the info page, we can change the name of the function. Let's call it LED button test. We can update it, so the name will get updated, or we can just delete the function. All right, getting to our APIs list. So on this button right here on the top right side, you're going to see there's a list of APIs, which are blocks of function that are really pre-made by us, so you can write your functions much faster. We have a set of general APIs. We have a section of variables, so for reading, writing, and other functions for variables. We have a bunch of blocks of functions for timers, alarms, and a stepper. Okay, so let's see just in the first section here in the APIs list. So let's take a look at the general APIs. So in the general APIs, we have a bunch of little functions that are not necessarily related to any variables, writing or reading, but they're pretty useful if you need to do for a certain type of operations. So let's look at the comment one first. So as a first thing, when we write a comment, that means it's a piece of string or a text that you can write inside your function, but they're not executed by the system at all. So for example, we want to write our first function is here. You can write anything you want as long as you put a // in front of this line. So you can see that this is in green. So if it's in green, you can write anything you want, and it's just for you to write comments. So for example, if we go one line below and we write comment, here we have comment small and comment title. So this is just 2 little pre-made pieces of text that we've done for you. So you can write comment title, for example, and here this is useful to write, for example, this is my first function. And then if we type and new line, comment small. This is just a very simple comment, just like the one before. Again, this will not be executed by the code, so you can write anything you want in here. Once you're done writing something in your function, you can save it by clicking this button. Once it's saved, it will stay inside the system, but it's not actually uploaded, so it will not be executed. So it's saved. So for example, we go back to devices and then we go back to functions. This is still here, but it will not be executed until we click this little button right here that now it's blue. This is upload function. And you also see it on the left side of the functions list that this has a little arrow up. So once we click this upload function, now it's actually being executed. All right. Now we're going to talk about functions rules. So Plexus Lab executes all the functions that you have here on the left from top to bottom if they're active every 100 milliseconds in a loop. So that means that Plexus Lab will collect all the data from your IOs, do all your functions, and send out outputs that needs to go to your IO system within a certain amount of milliseconds, but everything will be repeated every 100 milliseconds, so 10 times each second. To give you a quick example on how a function is written, we're going to start with a very simple if-else statement. Now, if-else statement is pretty much what you're going to use most of the time to write pretty much any function for an industrial system or for your lab. So let's start with a very simple one. And we're going to do that if we press, for example, this button right here, which is button 1, we're going to turn on the red LED strip right here. So we're going to start by typing if. As you can see, I get some autocomplete messaging, so I can do if read, for example. So here it says if read val, which is one of our APIs. So it's to read the value of any variable inside Plexus Lab. We can do if read val button 1. As you can see, it auto completes and it tells us the button 1, it's the device variable. So just press enter. Oops. It's equal to. So equal to, it's written like this. So equal to 1. If we want to do different than 1, we do exclamation point equal to 1. If we want to do more than 1, just do like that. Less than 1, or more than equal than 1. But in our case, we want to see if button is actually to 1, so that means the button is pressed. And inside here, we're going to write a variable. So write val. And we want our red to be value 1. Otherwise, if the button is not pressed, because it's not going to be equal to 1, we're going to write val red equal to 0. Okay, so now if we save the function and upload it, we see that it's active. So now if we press button 1, the red LED will turn on. When we release button 1, the red LED will turn off. Very simple function. Now, one very useful thing you can do is if you don't have access directly to your system over here, but you want to just see what's happening inside the function. Here we can write debug, I showed before, red is on, and then also copy this and paste it right here, and it says red is off. So what's happening is that if we save it and upload it, now we can open the debug. It says red is off. If we press this button now, it will say red is on. If we let it go, red is off. So this is very useful for you to print and see where which portion of the code is now executed. Now we're printing this if if button is pressed. Otherwise, we'll go into this section of the code. Okay, so as you noticed, when we have an if statements, we need to put the brackets here. After this, we don't have to write a semicolon. If we put a semicolon, there will be an error. But every time we write a line, so this is the only case when we put these brackets, we don't need to put a semicolon. In any other case, at the end of each line, you need to put a semicolon to close it. If we do this, for example, we see that we got an error. So this is unexpected to be here because we need to put a semicolon in this position. Okay, so this is a first very simple function. Now, another rule is that the last functions wins. So that means that if, for example, we write the blue LED to be 1. So this is not, it's not inside any condition, so every time will be executed. So that means if we save this and upload it, the blue button will be on and will always be on no matter what we do because we're telling it to be on. Now, if we write in a second line, the blue should be 0, what happens is the second part win because the system will go inside, says that it needs to turn this one on, but then immediately after we'll see that this one should be off. So that means that in the execution, the last one that it's written is the one that wins. Now, if we create an additional function, we call it last, and we take this line, copy it, go into the last function, and say that the blue should be at 1, save, upload. As soon as we activate it, you see that this blue is on. No matter if the first function said it should be 0, even if we eliminate this one and save it, because the last function win. So everything is executed from the top, going second, third, fourth, fifth, and this is the sixth and last function, so that means that this wins. Now if we edit the order of this function and put it on the top, that means that LED button test will be after last, and once we save it, you can see that it will be turned off. So very, very important. So when you're writing your function, you can start writing some logic, but then make sure that, for example, your safety function, you put it at the bottom. So anything can be blocked if there's some particular case in a system that you need to have something shut off. Okay, the last thing I'm going to show you here in the rules is how to use internal variables. So for now, for example, this write val that we've seen, we're actually writing variables that are either in the devices or in the sections. But if we want to have a variable to just be used for calculations or for something else inside Plexus Lab, you guys can just write like plx vars, internal variables, and for example, give it the name test. Here you can choose any name you want, as long as you use a unique for each variable you want to use. And for example, we give a value of 10. Now, this variable is now being used and saved, so we can actually use it in another function. So now we're inside last. Let's go into LED button test, and here write debug message, and we can write the value of test is text. As you can see here, you can write a value of any text. You can write any text you want inside the debug message. And since this is all written in PHP, it follows PHP rules. So to concatenate text, so to attach this text with the value of this variable, for example, I can just do the text inside here and then put dot and then plx vars test. So if we save this and upload it, it's going to say now the value of test is 10. So even if this plx var test is not inside the specific function, it's been declared up here as given, and it's been given a value of 10. Okay, so for now we've seen that we can use read-val and write-val and other functions blocks that are being pre-made by us. You can use them. We only saw a couple, and in the next video we're going to see many other ones. But if you want to write your own function blocks, like something like this, you can do so by going into include functions. So all these ones, the functions you create yourself, are generated, are going in a loop every 100 milliseconds. Where include functions, is only executed at startup or whenever you restart a system. So here you can write a series of function blocks that you can use inside your automation logic. So here we wrote a very simple example, a little function that sum two values together and return the sum. So the way we do it is that you come here and you write a function like this. So for example, function return sum of v1 and v2, and here's the sum. Remember that all this is written in PHP, so you can go online and search how to write PHP functions, for example, and then we return the value of the sum of the two. So once you do it, remember to save, upload, and then in this case, only in this specific case, you need to go to System and then restart the system so that function block that you wrote goes into the general system and it can be used inside functions. So once you do all that, you can go into any of your functions here in the list. And for example, I assigned two values to plx var test, I give it 10, and then plx var test 2, I give it 5. And here, just by printing a little debug message, I put sum of two vars is, and then the dot to concatenate strings. And then here I wrote my function block. So this one doesn't exist in the function APIs list, but since we just added it, we wrote return sum, and then we put the two values here. So if we open the debug view, now we see the sum of two vars is 15. 10 plus 5. Okay, you can write as complex functions blocks as you want, but this is very useful if there's something in our API list that you didn't see, or you want to create something to be reused many times inside your logic. For example, here I could use this for many different variables, and this is already a pre-made piece of code that I don't have to write all the time. Okay, so now that we've seen just the general structure and a couple of rules, I'm going to go through and write a little function as an example for you. Before then we get into the next video where we're going to talk about all the APIs and a little bit more in detail. Here, let's say we want to write a function where if we put the selector to 1, we're going to turn on light 1. If we put it selector to 2, we're going to turn light 2. And if we put selector to 3, we're going to turn on the 3 lights. And if we go back to 0, they all shut off. So let's use this one, for example. So very simply, we start by printing if. And then inside the parentheses, we want to read the value of the selector 1. So if we have selector 1 that is equal to 1, we want to make sure that we write the first LED light to 1, and we also want to make sure that the light 2 and 3 are going to be off. 0, 0, light 2, and light 3. Okay, let's test this out very quickly. So we have, all right, so selector 1. All right, we see that now light number 1 is on and the other 2 is off. Okay, nothing else happened because we only went to selector 1. This was turned on, and there's no other instruction to do anything else. All right, now let's do if selector 2 is selected. We want light 1 to stay on and light 2 to go on also. Selector 3. We want all 3 to be on. Okay. And in the case that selector 1 is equal to 0 and selector 2 is equal to 0 and selector 3 is equal to 0. So here we have a situation where all 3 are 0, so that means we didn't select anyone. We want to turn off all the lights. So we put 0, 0, 0. There is a little bit more efficient way to write this, but this is a very simple example, so let's go through it again. If we have selector 1 is equal to 1, then we want this to be at turn on only light 1. If it's equal to 2, we want 2 lights to be on. If it's equal to 3, we're going to go 3 lights on. If all of them are off, so that means we're in the 0 position, then they should all turn off. So let's test this out. All right, so all the lights now are off. We go 1, 2, 3, and then if we come back to 2, they become 2, 1, and 0. All right. Now, as you noticed, this blue LED strip is on because we have this function on top that says to write blue to 1. So let's take that out of there. And let's say we want that blue light to be off. We can write it at the top here. Keep it off. All right, one thing to notice. So now I forced the blue light to be off. So that means if we go back to devices, we go in our pod, and we go where the blue light is, and we try to turn it on, it will show it to us, but then go back to 0. That means like we can try to turn it on as many times as we want, but the functions are actually forcing this blue light to be off. Now, the red light, for example, it's not controlled by anyone. So we can control it as we wish, because there's no functions taking over, right? So the functions will always take over before the UI, right? Because if there's a function running in a system, even if we want to try to turn on the blue light, but the actual logic says that it should be off, then obviously we cannot turn it on. All right, that was a very simple example. Just as another example, we can use a little function block called write val period. So we can say if read val, let's say button 1, which is this button over here, equal to 1. We can start blinking on the red LED strip here. So we can do write val period red, and he's going to tell us what's the first value should be. So we want to trigger between 0 and 1 at a speed of let's say 200 milliseconds for 0 and 400 milliseconds for 1. So this little block here says that the red LED strip should be 0 for 200 milliseconds, then 1 for 400 milliseconds, and it will keep looping like that. Otherwise, if we let it go, we want to write it to simply red to 0. Okay, let's see what this does. All right, it's now cycling through this write val period. When we let it go, it will automatically turn off. All right, I hope this was useful, and please leave us a comment below if you have any questions, and see you in the next video when we're going to go through all the APIs list and a little bit more complex examples. Thank you.